All right, let's graph some linear inequalities. For this one, y is greater than or equal to 2x minus 1. In part A, what I ask you to do is to identify the slope and the y-intercept. Since this is in slope-intercept form, it's pretty easy to do. The slope is the coefficient in front of the variable, 2. And the y-intercept is the constant that's added to it, the negative 1. So we're going to start with the negative 1. That's going to be the y-intercept. Then we use the slope, 2, remembering that it's 2 over 1, to go up 2 and over 1, and that'll give us our next point. Now that we're getting ready to actually graph the line, we have to know whether it should be a solid line or a dotted line. That part is determined just by the inequality itself. And since this one is greater than or equal to, that means that the line we draw is going to be a solid line. So as I draw it, no need for dashes or anything like that. There's our line. And the next and final thing really to do in order to get the graph right is to determine which side should be shaded. And that's where part B comes in. In part B, I ask, is the point 2, 1 a solution? And all we have to do is take the x-coordinate and the y-coordinate and plug it into the inequality, see if it's true. So since this says y is greater than or equal to 2x minus 1, my y is 1. And I want to see if that is greater than or equal to 2x minus 1 when x is 2. So just simplifying a little bit, I got y is greater than or equal to 4 minus 1. Is 1 greater than or equal to 3? Well, no, that's ridiculous. 1 is smaller than 3, not greater. And the point 2, 1, 1, 2, 1 is right here. And that is not a solution, which means all of the solutions have to happen on the other side of the line. So that's the side of the line that gets shaded. Let's try another one. Y is less than 1/2 x. So in part A, again, I want to know about the slope and the y-intercept because this is also in slope-intercept form. Here the slope is 1/2, and since nothing is being added after the x, the y-intercept is 0. So we plot the 0, or the y-intercept at 0, then we use the slope to go up 1 over 2, and there's our next point. Now we have to determine whether it should be a solid line or dotted. So we look at the inequality. This one is strictly less than, not less than or equal to. So that means when we draw the line, it has to be a dotted line. So let it just leave a break in between every so often. Finally, we have to determine which side to shade, and that's where part B will be helpful. I want to know, is the ordered pair negative 2 a solution? Well, plug it in. The y-coordinate is negative 2. Is that less than 1/2 of negative 2? Is negative 2 less than negative 1? Well, yes. Yes, it is. So now we have to determine where is that negative 2. It's fairly close to the line. And on the axes that I've drawn here, it's not exactly easy to see. But the one that's on your review sheet is a lot easier. If I go back to where is the line? Well, on the other side, if I went over 2, I went up 1. So that means if I go back 2, I went down 1. And the point that I'm looking for is back 2, down 2. So this is the point I tested, negative 2. And yes, it was a solution. That means we have to shade on this side of the line. One last line, in a different form this time, 2x minus 5y is greater than 10. Notice that I don't ask you for the slope and the y-intercept anymore. Now I ask for the x-intercept and the y-intercept. Because when it's in standard form, this is the way to determine where the line is. How we find the x-intercept is by plugging 0 in for y. So if I have 2x minus 5 times 0 is equal to 10, that means 2x is equal to 10, and the x-intercept is going to be 5. On the y-intercept, we'll plug 0 in for x. So 2 times 0 minus 5y is equal to 10. This term will be 0. Negative 5y is equal to 10 means that y is equal to negative 2. These are the two intercepts. When we plot them, x will equal 5. So on the x-axis, we go over 5 and put a dot. On the y-axis, it's y is equal to negative 2. So we go down 2, put a dot. And there are the 2 points that are going to determine the line. Next, we need to figure out, should that line be a solid line or dotted line? Since it's strictly greater than and not greater than or equal to, it's going to be a dotted line. So I'm going to draw my dotted line all the way across the graph, include a couple arrows. And now we have to figure out which side to shade on. So in part B, I ask, is the ordered pair 0, 0 a solution? A nice easy one to test, because when we plug in 0 for x and 0 for y, that whole side is 0. And is 0 greater than 10? No, obviously not. Since 0, 0 is the origin, that means we need to shade on the other side of the line. And that's graphing linear inequalities.